Okay, so we have like and unlike fractions. If I have 2/5 and I have 3/4, are those like or unlike fractions? So,
Unlike.
yeah, and the way we can do it is we can either make something like a graph and we can fill it in. And that's one way to do it, and that's awesome. And we can say, are these the same amount as these? No. So, an easier way to do it instead of graphing it is to find an equivalent fraction, which means we find a common denominator, which is 20. And then we do our multiplying by whatever to get it to 20. And whatever we do to the denominator, we do to the numerator. And then this is going to tell us whether they're equivalent fractions, which means equal fractions. So this is 8/20 and this is 15/20. And we can also see which one is bigger. So which one is bigger, 2/5 or 3/4? And then not only does this tell us these are not equivalent fractions, but it also tells us that this one is greater than. So what they're saying is to find out whether these are equivalent fractions, you can multiply them up, and you can also do this to find an equivalent fraction. So I want to find out another fraction that is equal to 3/4. I can multiply this by 2, I can multiply it by 3, I can multiply it by 4. And as long as I multiply both the numerator and the denominator, I'm going to get an equivalent fraction. So 3/4 is the same as 6/8, it's the same as 9/12, and it's the same as 12/16. Now, sometimes we can find a number like 6/9, and we can multiply those up to find equivalent fractions as well. But for this one, we can also divide it down because it has a common number that divides into 6 and 9. Can you unmute and tell me what that common number is? What can I divide 6 and 9 by?
3.
Yeah. So for a fraction that shares a common number to divide down, we can either divide down or we can multiply up. As long, our only rule is whatever we do to the denominator and numerator, we have to do to the other. So to find equivalent fractions, we have multiplication always. We can always multiply up as long as you multiply up the numerator and the denominator by the same number. Then rule 2 is we can divide down only if, so this one we can do it all the time, but this one we can do it only if they share a common number that we can divide down by. Does that make sense to you?
Yeah.
Okay. Now they're going to go on to improper fractions and mixed numbers. So they're using 5/3 as our number, and they want us to model that out. So the first thing I have to do is make 2 circles, and I have to divide them into 3 parts because that's my denominator. My denominator tells me how many pieces I break my shapes into. Then my numerator tells me how many I'm going to shade in. So I might need to do a 3rd circle, but for this one, 1, 2, 3, 4, 5, I only need 2 circles. And this is going to tell me what the mixed number is. I have 1 whole, and then I have 2/3. Do you remember turning improper fractions into mixed numbers, Lila?
Mm-hmm.
Awesome. The other way to do it is just say, how many times does 3 go into 5? It goes in 1 time. How many's left over? 2. And then rewrite the denominator. So there's 2 ways to find, and they're probably going to ask you both ways because in the book, they're asking both ways. So I'm going to ask you to do this one for me. So you can unmute and tell me what 19/5 is as an mixed number.
Three.
Yeah.
Is it 3, 4, 5?
Yep. And then the opposite is to change a mixed number into an improper fraction. So for that, we do denominator times whole number plus numerator over denominator. So we would do 6 times 2 plus 4 over our denominator of 6. So I know 6 times 2 is 12 plus 4 is 16 over 6. Can you do that for this number, darling? 1 6/10.
16 over 10.
You got it. Okay, now we're going to rewrite division expressions as fractions. So they're saying that we have 2 fruit tarts and we're going to divide them into 3 equally among 3 children. What fraction of a fruit tart will each child receive? So this one, and this one is going to go to 3 children. So we're going to do child 1, child 2, child 3, child 1, child 2, child 3. So each child is going to get 1/3 of this one plus 1/3 of the green one. So they're going to get 2/3 of the fruit tart. Does that make sense to you?
A little bit.
Okay. The next one is the same thing. So Mr. Brown cuts 3 strawberry pies equally among 4 children. So child 1 is going to get this one, child 2 is going to get this one, child 3 is going to get this one, child 4 is going to get this one. And then child 1 is going to get this one, child 2 is going to get this one, child 3, and child 4. And again, same thing. So then I'm going to count how many child 1 gets. They get 3 out of 4 pieces. So 3 would go as the numerator and 4 would go as the denominator. Kind of makes sense?
Yeah, and I have a question.
Yeah.
Why does it, how do you explain it? Like, I would draw a circle for, and then cut it into.
You mean this one? Yeah, I don't know why it's confusing. Yeah.
Why do you put like the 3? Because they only have 1 of each one, and there's 3 pies in there.
They're trying to say child 1 got this one, child 2 got this one, child 3. So they made 3 separate plates that each child got. So one child got this one, then they got this one, then they got this one. They didn't get a 4th piece. I get what you're saying. It's kind of confusing. But basically, whatever the numerator is going to be the number of cuts, and the denominator is going to be the number of children. So this becomes your numerator, and this becomes your denominator. That's kind of the shortcut way to look at it. And then basically what they're saying is, here's child 1, here's child 2. It's like, this is the pies, and they get a slice, and they get a slice, and they get a slice from each one. And then they're showing each of the plates that each person gets. So how many pieces did they get? They got 3, and then they didn't get this 4th piece, which is why they got 3 out of 4 pieces. It is a weird way to explain it, but we got to go with what they do, Miss Lila. So for this one, 4 divided by 5, 4 becomes the numerator, 5 becomes the denominator. Five becomes the numerator, 8 becomes the denominator. 7 becomes the numerator, the second number becomes the denominator, so 9. So for this one, we do the opposite. We're going to say this becomes the numerator, and this becomes the denominator. So this would be the first number divided by 7. What do you think would be the first number for 8? What would I put in this blank?
8.
Yeah. And then what would I put in this blank?
12.
You got it. What would I put in this one?
5.
And then what would I put in this one?
6.
You got it. All right. So that is what they are doing for a long, long time. And then in section 2, they're adding unlike fractions, which hopefully you remember you did really well with that last year. So the first thing I do is find my common denominator. So I'm going to count up by 2s until I get to a common number. My common number is 6. So I turn this into a 6, and I turn this into a 6. And in math, I can't just change a 2 to a 6. So what would I multiply my 2 by to get it to a 6, Lila?
3.
And then anything I do to the denominator, I do to the numerator. So what would this numerator become?
That would become 3.
And then what would this denominator become?
That would come, or what denominator?
So I can't just change a 3 to a 6, so I multiplied it by 2. Anything I do to the bottom, I do to the top.
The numerator would be 2 for 1 over 3. First.
And then now that I have the same denominator, what do I get to do?
Add
Yep.
2, 3, and 2, and then
Yep. And then if this was a subtraction problem instead of an addition problem, I would do the same exact steps, except for my last step would be to subtract the 3 and the 2, and it would be 1/6. Does that make sense?
Mm-hmm.
If this was a mixed number like this, I would do this problem exactly the same, and then I would deal with the whole numbers. So 4 minus 1 is what?
3.
So my answer would be 3 and 1/6. Does that make sense, my darling?
Yes.
Beautiful. We have now gone through section 1, 2, and 3 of the next chapter. So I doubt you will get that far by the next time I see you. So that is good. Any questions before I stop the video, darling?
No.